So fine. So fine. Guys, up to now we already discussed about what is the use of data science, what is the use of AI. Okay, so we are going to we are already discussed about some of the things about the AI and some of the things about data science and how exactly they are going on, everything, right? So these are the things we already discussed. Now today we are going to see one of the practical way implementation, how we are going to implement one type of projects using this machine learning and implementing things, right? So for that we already mentioned like Kaggle is a place, it's a type of website. It's a place where you can easily identify the data set which is related to the AI, right? Which is related to the AI. So let me click on the data set. So these are the complete data sets. These are the complete data sets. Data sets which is helpful for designing the models and which is helpful for the natural language processing, NLP or machine learning. So we have a n number of things. So if you want to work like the different types of domains. So data set is a collection of information. Okay, it's a collection of information where we can easily find the different types. Okay, where we can easily find the so different types of information based on the things. So business related or computer science related, classification related, so on so we have a lot of things, right? So today I'm going to show you how to implement one type of project like using machine learning in the different types of data set. So for that I need to download one type of data set, right? So that is USA house price. So this is a data set completely based on the US. So house price prediction. So let me download here. So or you can also download from here also. So data set is downloaded. Let me extract this data set. So data set, yeah, extraction has been completed. So let me show you the data set file. Let me go and this is the data set file, right? So this is the dataset file. So we have a total number of rows and columns, and it have a 1 0 to around the 7 columns. It has presented 7 columns, and these are the all the almost of the data. Okay. So previous class we already discussed about the dependent and independent columns, right? We already discussed about the dependent and independent column. So based on these entire columns, so based on these columns, the price is dependent upon each and everything. So for example, let me take a Indian related houses. So in India, the price of 1 BHK flat is different. The price of 2 BHK flat is different. The price of 3 BHK flat is also different, right? So based on the location, based on the square feet of a area is completely depends upon the things, right? It's a completely depends upon the things. So like that only in US also, based on the area, based on the house measurement, based on the things as the price is also dependent. Same like the India. So this is the data set. So let me change this location, dataset location in another file. So going to the user, and this is my folder where I can work for the data science related projects. So this is the place. Yeah, it's also working. Let me remove this. So dataset has been changed the location. So let me open my Jupyter notebook. So Jupyter notebook is simply known as a IDE where we can perform some of the projects, where we can perform the logics and write the code. So same like that Jupyter, we have a VS Code, PyCharm, like we have a number of things. So my preference is good to work on the Jupyter because almost everyone using Jupyter to work. So simply click on new. I need to create a new notebook. Let's simply call that as a notebook. Okay. So notebook. Now we are going to see on how to implement the machine learning model by using this US data set. Okay. So first, before working on any data set, we need to load the libraries. You need to load the libraries. So libraries are NumPy. We already seen about NumPy, right? As NP import pandas as PD, import matplot lib.pyplot as PLT, import cbond as SNS. So these are the fundamental libraries. We already discussed about some of the things like matplot. Sorry, spelling mistake. It's my mistake. Now it's executed. So Matplotlib has PLT and C1. So Matplotlib and C1 both are used for the data visualization purpose, whereas Pandas is used for the data analysis, manipulating related purpose. Whereas coming to the NumPy, NumPy is used to deal with n-dimensional array. Now, next we are going to load the data set. Now we are going to see the how to load the data set. So simply I'm creating a one type of variable. We call it as a variable. A data equals to pd dot, I'm using pandas and pd dot read underscore csv. I'm reading the file. So, but before going to read the file, first we need to check which type of format we have. So it is in the format, and I'm not getting this format. Securities, previous, customize. So let me show the formats of the data. So it's a CSV file. So that means we need to load the CSV file. We need to load the CSV file, right? So CSV and the path of a data, I need to provide the path of a data file and .csv. So done .tsv. So let me run this. So dataset is loaded. Now I'm going to view the top and bottom rows of a data. View the top and bottom of a rows of a data. So for the data.get is a method which shows the top 5 rows of a data. So these are the top 5 rows of a data. Same like that for the bottom view, data.type. So these are the bottom view of a data. So we can see the top 5 and bottom 5, but we don't know how many rows and columns presented, right? So to check number of rows and columns. To take number of rows and columns. So this is the function data.shape. If you use this function, it shows the number of columns and rows. We have 5,000 rows present in a data set. And only 7 columns. We have 7 columns. And we need to find the mean, count, minimum value, 25%, quartiles, like this. So that's why we need to show the statistical description. Statistical description of a data. So data.describe. If you use this data.describe, it shows the statistical description of a data. Let me write this method. So we can see in average area income, the count is 5,000 rows. If you find the mean of this average area of income, if this is a mean. This is a mean of a average income. Okay. This is a mean. Same like the standard deviation, we can easily identify the standard.
Screen, it is not visible.
Screen is not visible. Okay. Just a second. Now is it visible?
Yes, sir.
Yeah, fine. So let me run from the starting. Let me show you from the starting.
So can you please repeat it?
Yeah. Let me start from the. So first, the most important thing is we need to load the libraries. Okay, libraries is the most important. So because we need to work on it. So that's why I'm importing NumPy as NP. So this is where we can work in n-dimensional arrays. So whereas pandas as PD for data analysis, data manipulating related things. Next, we are going to see matplotlib. Matplotlib.pyplot. It is a one type of package which is used for the data visualization purpose. And final one is Seaborn. It is also advanced data visualization. It is also used for the advanced data visualization purpose. First, we need to load these libraries. After loading, the first thing we need to try to load the data set, because we need to work on the data set, right? We need to load the data set. To load the data set, first we need to check the properties of a file. This is a USA housing price. This is the data set, right? So first we need to check the properties of your data file. The type of file is CSV file. By using pandas, we need to read this file. Data equals to pd dot, data equals to pd dot, okay, data equals to pd dot read underscore. I need to read the CSV file, right? And I need to pass the path of a data set. Path of a data set. So this is my path of a data set, and USA space housing. This is a file name, and it is the extension of CSV. Right? It is the extension of. Let me load this. So data has been loaded, and it make a missed error. We get an error. So no such a directory we have for. Let me. So it's a underscore, right? Let me stay has been done. Now it will be loaded. So data set has been loaded. Entire data set is loaded into this variable a data. Okay. So I need to view the top and bottom columns or rows, but top and bottom rows. So to view the top and bottom rows, we have two methods. Data.head, it is used to view the top rows, whereas data.tail, it is used to view the bottom rows. It is used to view the bottom rows, top rows and bottom rows. But we don't know how many exactly rows is presented. We don't know how exactly columns is presented. So to view the number of rows and columns, to view the number of rows and columns, we have one type of method, data.shape. If you use this method, it will show the total number of rows and total number of columns. Total number of rows and total number of columns. We have 5,000 rows and 7 columns. We have 5,000 rows and 7 columns. So next, we need to see the statistical description of a data. Statistical description of a data. We need to see statistical description of a data. For the data.describe, this is a method, data.describe. If you use this data.describe, it shows some statistical description. Count, mean, standard deviation, minimum value, 25 percentile, 50 percentile, like 25 percentile value, 50% value, 75% value, and maximum value. So it will shows like this. It will shows the like this. So I need a complete information. I need a complete information about the data set, about data set. Okay, if you want complete information about the data, you need to use data.info. You need to use data.info. If you use this function, it shows the complete information of a data. So it shows the number of columns we have, it shows the number of rows we have, it shows what are the columns we have, and is there any missing values present in a data. It will show each and everything, and the type of columns also. So most of the cases we have float 64, only float values, which is the form of decimals. And also it also provide the memory usage, how much memory is required for to store this file. It also shows like that. Okay, this is a thing. So if you want to identify, find the null values, that means null or missing values, null or missing values in a data, If you want to find any missing values in a data, we have two types of method. One is data is nan, it is a one type, or you can choose the another type, data dot is null. Data dot is null. Both methods are used to identify the missing values or null values. So here everything is false, false, false. And right now this is the same method also, you can use the false, false also. So we have a 5,000 of rows, right? We can't able to get how many exact count of a null values. So to get the count of a null values means simply like a missing values. To get the count of missing values, so we need to use data dot isNan dot sum. If you use this data dot isNan dot sum method, it will shows the total count of null values. You get 0, 0, 0, 0, right? That means there is no null values present in this data. That means there is no null values present in this data, right? We can easily, if there is a null values present in the data, it shows the count of null values like 10, 20, 30, 40. It shows the numbers, counting numbers. So that means we have that much of null values present in a data. That means we have that much of null values present in the data. So this is the some basics. These are some basics we are doing, right? Some basics we are doing on this data. So next we see that how the data analysis, like these are the completely as a data analyst, right? So we already discussed about data analysis is a work where you need to perform some analysis on the data, where you need to work some analysis on the data. So if you want, like, let me show the data again. Let me show you the data again. So data dot head, if you use this top 5 rows, so we can see we have a n number of things present in address. Like address is not good at all looking. Like we have a numerics and we have a missing like alphabets and some special characters. Now I'm going to drop this address, drop the column. If you want to drop the any column, you need to write data dot drop. I need to drop. What you need to drop? Address. I need to drop the address. I need to drop the address, and axis equals to 1. Axis equals to 1. If you mention this axis equals to 1, it will check the column by column. If it will check the column by column, first it will go for the average area. Is there any address? No. Next it will go for the area. Is there any address? No. Like that it will check the column by column. And you also mention the in place equals to true. In place equals to true. If you mention in place equals to true, it will change the, it will occur the permanent changes. It will do the permanent changes. Let me write this and dot head. Let me see the top layer. So now area, now you can see that address has been missed. Address is drop. Address is drop. Okay, you can see that address is drop right now, right? Address is drop right now. Address is drop right now. Okay, clear? Now we are going to see, like, this is a simple analysis. Just we are doing some simple analysis. Now we are going to see the visualization. Now we are going to see the visualization. Okay, so visualization is a, like, simply we can represent some stat like a graphs. Simply we need to represent the graph. Okay, simply we need to represent the sum. So first, so I mentioned like Matplotlib and Seaborn both are used for the visualization, right? So let using the same thing. So Matplot SNS dot pair plot, SNS dot pair plot. This is a one type of plot. You need to pass the data. You need to pass the data. So let me give you some time. It will execute the pair plots. It will form the visualization. It will form the visualizations. So just give me a few seconds. So these are the visualizations. These are the visualizations. Okay, these are the visualizations we have. And next, let me go for some more visualizations also. So same using the advanced data visualization, SNS dot heat map, SNS dot heat map, and I'm passing the data dot correlation. I need to identify the correlation, and anota equals to true. If you mention the anota equals to true, it shows the values. It shows the values. So you can see. So these are the anota values we have. So this is the one type of graph. So this is a one type of graph. So let me go for visual some more. SNS dot dist plot. SNS dot dist plot. I'm passing the data. I'm passing the data and the price. The price. So you can see. So this is the distribution of price. This is a distribution of price. This is the distribution of price. Okay, this is the distribution of price. So let me show you how to see these types of things. Means open the C1 package, and if you want to draw any relationship, or if you want to draw any categorical, or if you want to draw anything, like, you can simply go for these tutorials and you will find some histograms. So here we have a histogram, right? Simply copy this code. You can easily work on it. So simply copy this code, and I'm copying this code. I'm coming to the file here, and where data equals to data, I'm passing the x-axis. So what are the values we have? So area of income. So let me draw the area of income, right? Let me pass the area of income. So I need to pass this in histogram. So if you run this, It shows the output as an error. So you need to you could not interpret the values of x. So it means it's showing the error as a x values is not interpreted. So that means you need to change one more parameter also. Let me where the exactly data is present. Yeah, let me take this also. SNS dot, and I need to pause the y-axis. So it's the same output is showing, and where you could not interpret the values. So for example, if you get any type of errors in the real time, simply copy this error, paste over the Google, paste in the Google, and paste in the Google. And this is a Stack Overflow is a place where you can easily identify the errors. So the error is we can't able to interpret the y values and this value, right? We can't interpret. So that's a error. So here the x is a parameter, could not have a value of x. So how can we solve means they already mentioned something like okay, you need to find this data equals to okay. So like this you need to give the axis. Like this you need to give the axis. At the time you will get the information how we can easily create these things. How we can easily create the things. And let me use the one more related things. Okay. We have a n number of things, right? So we have this histogram plots is a different type. Let me open some of the other types. So mostly mostly in our data set, we have only these are the highest values. So everything is in a floating related things. That's why showing the huge amount of PLs are not able to apply there. Okay, that's the main error we have getting. And now we need to build a model, right? We need to build a model. So first, before building a model, let me view the data again. Data.head. Let me view the data again. So we have a huge amount of values. We have a huge amount of values. So if you train this data same for the algorithm, the data like training time will be take more. So that's why we need to normalize this data. We need to normalize this data. So we need to reduce in between the zeros and ones. We need to reduce the data between zeros and ones. For that purpose, I am using from sklearn. It is a one type of package. sklearn import pre-processing. Okay, pre-processing. This is a package name. So pre underscore process equals to pre-processing processing dot standardization standard underscore scalar. If you use this standard underscore scalar, it's applied to some function. So no attributes of standard scalar. Let me remove. So yeah, standard scalar is done. So and I need to divide the data into the train and test. So we already discussed, right? We need to divide the train and test data. Okay. I need to put data equals data. I need to take the column names. I need to take the column like average income as a x-axis. On x-axis, I need to mention the average income. And next, I need to take average area of age also. I need to take average area of age also. Next, I need to take average area of number of bedrooms. Average area of number of bedrooms. Okay. And next, I need to take average area of rooms and bedrooms. Rooms has been taken, and now we are going to take a bedrooms and area of population. So these 5 columns I mentioned in x-axis. These 5 columns I mentioned in x-axis. Let me run this. So is there any errors will we get it? There, yeah, I got the error there is no words right. Let me remove this. Then I think the spaces with the help of spaces. Let me log in this. The same error I am getting. So what is exactly error is? So bedroom slash T is presented. So space of the bedroom is presented. That's why showing the error. Again, I'm showing the same error. We need to check the index of the area. We need to check the index of the area. So let me define multiple columns. Let me define with them multiple columns. The same thing, it's showing the not index in the range. It's showing the not index in the range. So where x equals to data, I'm passing the correct, right? X equals to data and area of population, and area of a population. So things presented, but area of the population has been get an error. So let me try with a different way. Okay, where x equals to data dot drop, and like let me drop data and dropping the price where axis equals to true, where axis equals to 1 and in place equals to 2. Let me try in the different way. Okay, let me done. So drop is not defined. Name drop is not defined. So it's showing the name drop is not defined. Okay. It's showing drop is not defined. We already done, right? Same thing. We already done. Let me copy the same thing. So data dot drop. I'm dropping the price. I'm dropping the price as a x-axis. Let me take an x-axis. So yeah, it's done. So where x dot head, it will shows there is no head function is presented. Okay, none, done. So there is no type of x is presented. So if you drop the x-axis, that means the data has been dropped. Okay. So same like that, I'm taking the y equals to data. Same like that, I am taking the y equals to price. Y equals to price. If I run this, I got error. There is no data is presented. Okay. There is no data is presented. Let me remove this axis, and it will shows. So just a second. It's still loading. So if you run it, so data is drop is done, data is done. So let me try with a different thing and the head of thing. So it shows the head of a data. So this is the X trend, and next I'm showing the white head of a white. So this is a head of a white. So you can see that this is a things presented, right? This is a things presented. You can see easily understand these things. Okay, you can easily understand this. So already we upload the here the pre-processing step, right? So let me try this x equals to pd dot data frame. I need to form the frame and the pre underscore what is the value created? Pre-process. We create the pre-process. We create the pre-process dot fit underscore transform. Fit underscore transform. So this is I'm transforming the x. So let me run. So x dot head, let me see it. So data is converted between zeros and ones. Data is converted between zeros and ones. Data is converted between zeros and ones. Okay. Now we need to separate the data into try and test. We need to separate the data from try and test. For that, from sklearn dot model selection, from sklearn dot model selection import. I need to split the try test split. This is a function. This is a library. From this library, we need to use. We need to split the data. So xtime, xtest, ytime, ytest, xtime, xtest, and ytime underscore ytest equals to try underscore test underscore split. Okay, I need to split the data. So x values, y values, and I'm taking the test size equals to 0.3% and random state equals to random underscore state equals to 45. So this is the let me run this. Yeah, model has been done. So let me see the shape of x prime. Shape of x prime dot shape. You can see the 3000 rows has been divided, and y test dot shape is around 1500 data is splitted. Now we are going to build the machine learning model. Machine learning model. Now we are going to build a machine learning model. So the model is I'm using linear regression. So one of the basic and important. So from sklearn dot linear underscore model import linear regression. The model is imported. Now I need to create an object. Create an object for model. Create an object for model. Okay, I need to create an object for model. Okay, so let me write lm equals to linear regression. This is a model. So model has been created. Now I need to train the data. lm dot fit x underscore prime comma y underscore prime. So I need to fit the data. So model has been done. The meta is also done. Now I'm going to see the. So linear regression is completely work on mx plus c, right? Y equals to mx plus c. So for that we need to identify the coefficient also. Let me identify the coefficient also. So print lm dot intercept also. So print lm dot intercept is this is the intercept lm 12,000 something is presented. This is the intercept value. So let me predict the values also. Y underscore predict equals to lm dot predict from the based on x test. So let me type this y underscore predict is also. These are the predicted values. These are the predicted values which was done by the linear regression machine learning model. This is the predicted value which is done by the linear regression of a model. Okay, linear regression model. So this is how exactly machine learning algorithm works. So we have a lot of algorithms, right? We have a let me open the scikit-learn package. Also. Scikit-learn package. So this is the scikit-learn package. So some of the classification and some of the regression models also we have. And let me open this logistic regression. So how we can work on this logistic regression also. So where is it? Is logistic regression. So everyone is showing, yeah, here the logistic regression we have. So how can we import this logistic regression means simply by using this logistic only. So from this sklearn.model import logistic regressor. From sklearn.model import logistic regression. Same installation. Like we need to import from the same thing, right? We need to import this from the same. So we have a different types of things. So if you want to work on the decision tree, so it's a one type of algorithm. Same, we need to import the decision tree. So you can see that. So we need to first import the decision tree. So like this, we need to import the decision tree, and we need to check the decision tree algorithm. Okay, we need to check the decision tree. So whether the working or not, whether the algorithm is working or not, we need to import. Okay, like that, we need to check each and everything as a machine learning algorithm. So this is a package where we can easily work for the machine learning algorithm. So we have a linear regression, decision tree, random forest, XGBoost, AdaBoost, and SVM. So these types of algorithms is presented. We need to check this model is working or better for that each and every one. We need to check the model is working for better or not. So like this, we need to identify this is the predictions. This is the predictions which is done by the linear regression. So this is the prediction which is done by the relation. By using this only the prediction, we need to convert this file into the user defined, like to create the user interface for the user usability. So if the users are mentioned some things, they can easily get the information. So this is all about your linear regression, how simply we need to build a model, how we are simply build a model. Okay.